This is Algebra 2 with trig, section 8.3. We're working again with graphing rational functions. So looking over our rules here, we see about X-intercepts where the graph is going to cross. So if we have a particular rational equation that might come down with our asymptotes and do something like that, it would cross the x-axis here. If we had an equation, the location of this would be where the top of the fraction, the numerator, the p of x, was 0. To find your vertical asymptotes, where the line comes straight down, what x value cannot be part of the equation, that is where the denominator would become 0. So in this case we call it q of x. Each 0 of q of x would be a vertical asymptote. Then to determine the horizontal asymptote, we have different situations. M and n are your exponents. M is the numerator's exponent, n is the denominator's exponent. So if m is less than n, so the degree of the top is less than the degree of the bottom, like we talked about in the past, then the horizontal asymptote would be y equals 0, because the bottom would grow so much faster than it would on top. If they're equal, if the degree of the top is equal to the degree of the bottom, then we would use the leading coefficients, and in this case they call them a and b. So if the m and n are the same, if they're both x, so x to the first power and x to the first power, the leading coefficients are where your horizontal asymptote would be located. And then in an extreme case, if the top's exponent is larger, then you get no horizontal asymptote. So what that would end up looking like, you would end up getting a slanted asymptote, and you might have a graph that looks like this. But we won't do this until pre-calc, so you're free on that one. So let's go ahead and try this. As we've done in the past, the first thing we want to do is find the vertical asymptote. So the vertical asymptote is where you set your denominator equal to 0. So our x squared plus 1 gets equal to 0 because we're looking for the vertical asymptote. So x squared, subtract the 1 over, take the square root, and you would get a plus or minus I. Because you can't take the square root of negative 1, so you get the imaginary number. So you have no, sorry, not horizontal, but no vertical asymptote. So we have none of those. We have nothing to draw on our graph. So next we're going to look for a horizontal asymptote. Now the horizontal asymptote, you have to pay attention to the exponents. As we discussed above, if m is less than n, then y equals 0 is the horizontal asymptote. We don't have an exponent on top for x. There is no x, so that means it's 0. You could consider it x to the 0 power, or you just notice there's none and it's 2 on bottom, so 2 is bigger than none. However you want to think about it, m is less than n, so y is going to equal 0. So we have a horizontal asymptote at y equals 0. So now we've done our vertical, then we did our horizontal. I like to put those in for some answers. So if we don't have right and left of a vertical asymptote, I would suggest to just use the 0, where x is 0. And if you plug that into your equation, showing work can be very helpful. plug 0 in, so you have 0 squared plus 1. So you get negative 5 over 1. And of course, that's negative 5. And then we can pick numbers off to the right. It looks like we have room to talk about 2, 4, and 6. So when x equals 2, we're going to plug 2 into our equation. So we're going to start with negative 5 on top. 2 squared is 4 plus 1 is 5. So that's a value of negative 1. When x equals 4, you get negative 5 on top. 4 squared is 16, plus 1 is 17. So we have negative 5 over 17. Well, that's very close to a half. And it's negative, so it's below the line. And when x equals 6, we start out with negative 5. 6 squared is 36, plus 1 is 37. So negative 5 over 37. And that's going to even be closer to 0. The neat part about so many of these, as long as we space out the same way, this is symmetrical. So when you plug in negative 2 and square it, it's going to be positive 4, and then you get the same results as you did before. So you get negative 1, negative 5 over 17, negative 5 over 37. So you get this shape that's going to come down here and come across. And we always like to write our equation on our graph. So, looking at your domain, what numbers can we type in? We're not limited to what we did. It goes forever to the right and forever to the left, so it's all real numbers for the domain. Now look at your range. Your range are all the values from 5 up to 0. That's the only spot. So it's not greater than 5, because that implies it goes up forever. It's not less than 0, because that implies it goes down forever. So it's your y value is greater than or equal to negative 5, but it only goes up to the 0. Interval notation, you could use negative 5, comma 0 with a parenthesis at the end. Square bracket includes the negative 5. Rounded bracket, it does not include the 0. So here we have negative 8 over x plus 4. We'll look for a vertical asymptote, which is x plus 4 equals 0. So x is going to be negative 4. That's our vertical asymptote. So that means we would put a vertical line. We like to draw it dashed so it doesn't get confused with the real graph. Don't forget to label it. We can look at our horizontal asymptotes. Again, notice that the degree of the top is less than the degree of the bottom. It's 0 on top and it's 1 on bottom. So we're going to have y equals 0. You can barely get that dashed line to show up, but make them thick enough so that they just about show through. No big deal. Label your asymptote with y equals 0. Then you're going to pick numbers. And there's plenty of room for us to spread out here a little bit, so I like to go by 2's. So we'll have to test those. X equals negative 2. Well, when we put into our equation, we have negative 8 over negative 2 plus 4, which gives us a total of positive 2. Simplifies. When x is 0, we get negative 8 over 4. which is negative 2. And when x equals 2, we get negative 8 over 6. 2 plus 4 is 6. So that's negative 4 over 3. So plotting those out, at 2, negative, we're down at negative 4, negative 2, and at 4/3. 4/3 is more than 3/3. 3/3 is 1. 4/3 is greater. So it's more than 1 down. So there's our first branch. Again, what's kind of neat about this is that if we go with the same spacing, we went by 2s, so if I continue by 2s, it's going to be symmetrical. You just got to figure out how it's symmetrical, and with this type, they're going to be in the opposite quadrants. So, and you can just test it. You know, negative 8 and plug in your negative 6, and you see you get negative 2. So negative 8 over negative 2 is positive 4, and positive 2, and positive 4/3. So it's a reflection of that from your x-axis. So we are at negative 2. It's really 6, but it's 2 more from your asymptote. 1, 2, 3, 4. And you write your equation. We know that the horizontal asymptote is y equals 0. The domain, you can plug in any number into your equation that you want, except where the asymptote is at. And you can get any answer except where the asymptote is at. You're not going to get a 0. No matter what number you plug in there, you can't get 0. So now we're coming down and we're going to look at cases where m is equal to n. So the degree of the top is equal to the degree of the bottom. The tables look a little crazy, but it's all done the same way. We start out with a vertical asymptote. We take the denominator and we set it equal to 0. We add the 4 across, we take the square root, and we get 2 answers. Whenever you take the square root of an equation on both sides, you're going to get a plus or minus type answer. So we have a negative 2 and a positive 2. So we're going to pick numbers to the right of your vertical asymptote. I don't have room to really spread out by 2, so I'm just going to go one at a time. And we test those out. So when you plug in 3 squared is 9. 9 minus 9 is 0. 9 minus 4 is 5. But that's still 0. When the top of your fraction is 0, you get 0. 4 squared minus 5, that's 16, or minus 9. 16 minus 9 is 7. 16 minus 4 is 12. So we get 7/12. That's really close to a half. We get 25 minus 9, which is 16. 25 minus 4, which is 21, so 16 over 21. So at 3, oh, you know what I haven't done yet? I haven't put in my horizontal asymptote. Maybe you noticed. So my horizontal asymptote, my degrees are the same. M equals n. And when those are the same, you're going to use the leading coefficient. So it's going to be 1 over 1, which is a value of 1. And label that onto your graph. We plot our points. When x is 3, y is 0. 7/12 is very close to 6/12. And then 11/16 is more than, actually 16. Wow. 16 over 21 is more than 10 and a half. 10 and a half would be half, so it's more than a half. It's closer to 1. So just trying to give you an idea of how to look at a fraction to identify what it is close to. You don't have to be exact. We can't plot a point exact. Now over here, since we went one at a time, we'll go one at a time. And when you plug those in, when you square your negatives, it's just like squaring a positive. So these are all going to be the same, exactly the same. Now we have this middle section. So I put my point halfway, which would be 0. And pick my numbers on either side, 1 and -1. So when you plug in 0, you're going to get 0 squared, which is 0. So you get 9 over 4. -9 over -4, which is 9/4. Well, 9/4. 4 goes into 9 twice. Twice and 1/4 left over. So 2.25. You can do that. And when x is 1, we get 1 squared minus 9, which is -8. 1 squared minus 4, which is -3. That goes in there twice with 2 left over, 2/3, 0.66 left over. So we're up here at 2.66, so it's a little bit higher than 0.25. So there's our crazy looking graph. And we write in our equation we know our vertical asymptotes were at plus or minus 2. Our horizontal asymptote was y equals 1. Our domain is still the simple one, being everything except where those asymptotes are at. X value, you can plug in any x value you want except the 2 vertical asymptotes. Now the range is tricky again. The range is not all real numbers. Notice that it is not in this section all the way up to 9/4. There's nothing in here. So it's all real numbers except for y values, except it's not at equal to 1 all the way up to below 9/4. Now a lot of people feel like it should include 9/4, but remember this is the except part. It is not at 1. It is not all the way up to the edge of 9/4. It includes 9/4 and higher. Alright, so now pause the video, give this one a try, and then watch the video and see me work through it. So go ahead and pause that. So we're first going to look at the vertical asymptote. And we set x squared minus 9 to 0. Add the 9 across and take the square root. So we get plus or minus 3. So we're going to put a vertical line at -3 and a vertical line at +3. Our horizontal asymptote, we notice that the degrees are the same, so m equals n. So we're going to use our leading coefficients, which is 2 over 1, known as 2. So we're going to have a horizontal asymptote at y equals 2. So now we're going to pick values, and I don't even have room to get 6 in there, so I'm just going to go one at a time. And we test them. So when we plug in 4, that's 16. 4 squared is 16. 16 times 2 is 32. 4 squared is 16. 16 minus 9 is 7. So 32 over 7. 25 times 2 is 50. 25 minus 9 is 16. So 50 over 16. 6 squared is 36 times 2 is 72. 36 minus 9 is 27. So 72 over 27. Well, I know that if this was 28 over 7, that would be 4. So this is more than 4. If this was 48, it would be 3, but it's 50. 16 goes into 48 3 times. It's 50, so it's more than 3. 81 would be 27 times 3, would go in there 3 times. But this is less than 81, so this is less than 3. And when we move to the left, we're going to have those same coordinates. 32 over 7, 50 over 16, 72 over 27. And we can plot those in just the same manner. Now we've got something going on over here. So the halfway point would be 0. And you can pick any numbers in here you wish. 2 and negative 2 would make sense. So when we test 0, 0 makes 0 on top. 0 minus 9 doesn't matter, because anything over 0, as long as it's not 0, any 0 over any number, not 0, is going to be 0. We're going to figure out what 2 is. So we got 2 squared, which is 4, and 4 times 2 is 8. 2 squared is 4. 4 minus 9 is 5. So actually a negative 5. So we have negative 8 fifths. And we'll get that in both situations here. So 8 fifths. 5 goes into 8 once, with a little bit left over. Doesn't really matter what amount left over, you just now know what side it is, and you know where it's approaching. Okay. Now, it is possible that the graph, this center graph could come down one side, cross over the horizontal asymptote, and then swing over to the other side. That does happen in some crazy graphs. When that's happening, usually your branches are in opposite corners also. Okay, so don't be surprised. The reason why you have a horizontal asymptote is for the extremes, is for the end behavior. So as this approaches, it's approaching the end behavior, is approaching that line. Sometimes it crosses and approaches from the top at that direction. Some weird parts that happen with these horizontal asymptotes. You never can cross a vertical asymptote. So your domain, what numbers can you type in? You can type any number in, except the asymptote. But now it gets a little complicated again for the range. It's this section right in here from 0 up to 2. Well, that's reasonable. So it's except when y is greater than. We don't want it to be, it is at 0, so we cannot say equal to 0 because it's except. It's not including. So it's anything greater than 0 up until you get to 2. Those are the parts that it cannot be at. Alright, last one. So here we have a food manufacturer who wants the most efficient packaging for a can of soup. The volume, they've already determined the volume has to be 342. They just don't know what the radius and the height needs to be. We're going to write an equation that gives the height of a soup can. Here's the formula for a cylinder. You have your cylinder of soup. The volume is 342, and that's going to equal pi r squared times h. Now if we want to write it in terms of the radius, height in terms of radius, so we want to get the height by itself. So we're going to divide by pi r squared, and we're going to have 342 equal to h. So your height is now in terms of h. Now we're going to write a function that gives the surface area of the can in terms of only the radius. So if you look at surface area, it has a height also, but I actually know what height is, so I can substitute that in and simplify it. So the surface area is 2 pi r squared plus 2 pi r h. And that's going to be 342 over pi r squared. Now we can look at this. We can cross those out. We can cross off one of the r's with that r. And we're left with 2 pi r squared plus 684 over r. So now the question is, graph the function of the surface area using a graphing calculator. So we're going to take our graphing calculator, hit y equals, and we get 2 pi r squared plus 684 divided by your radius. We can't actually put the r in, so we're just putting an x, but it stands for the same thing. And we'll graph it. Now I've already changed my window around. If you're doing yours from scratch, it would probably look something like this, which isn't telling you very much. Alright, you would need to look at your table, and if you notice that when it's small, you got really high numbers. So at 0, of course, we can't have 0 in the denominator, so that's why you get an error. We're up at 600, and it comes down a little ways, and then it goes back up. So by the time you get to, let's say, 20, you're up at 2,500. So if you go to Window, we don't need to look in the negative directions at all. We talked about going to 20. We don't need to look down at all because we don't have any negative numbers. And we need to go up to 2,500 or more. So now we can look at that curve around. Now what we want to find is this low point. What is the lowest location? So if we hit second trace, which is going to take us to calculations. We don't want to hit the trace button. It's not very accurate. But we want to go to minimum. And what minimum is going to require us to do is find, give me a spot left of the answer. I don't know where the answer is. But I know where it's not. I know that I am past it if I'm all the way climbing back up over here. So I hit my enter. Gives me a little barrier. Then it wants me to be on the right bound. So again, I don't know where I'm at, but I'm definitely going to be past it, so I'm climbing. I know I'm climbing by this point. Now it asks me to guess as if there's more than one answer, but I'm just going to get somewhere in the middle. It doesn't matter where you go. Does not matter. And hit enter. So I get my two values. This is my radius. That's my equation, was radius. And then this is my surface area. So I have a radius of 3.79, and those were in centimeters. And I have a surface area that is 270.73 centimeters squared. That would be my surface area. 3.79 centimeters, but I don't know what my height is. Height is not part of our graphing calculator. We didn't have an h in our equation, but we know what h is in terms of r. So if we come over here and say h equals 342 over pi 3.79 squared, I can type that in. Use, it's always good, but you wouldn't have to. Order of operations would take care of it, but if you have multiple things in the denominator, and we're going to get 7.58. That would be your two dimensions that you would need for you to maximize your volume with 342.